This lesson is about elements, compounds, and mixtures. We are going to be looking at particles that make these substances, how they are different and what they're all made up of, what's common to all these substances. And we are also going to be looking at chemical symbols and formulae, and to get an understanding of how formulae are written for these substances and how they are different as well. And we'll also learn about how, by just looking at the formulae, we can tell them apart. So we're going to start by looking at the key words. In this case, we got elements that are made up of just one type of atom. Don't worry about if you don't understand this right now, because when we go into the lesson, you will see diagrams of these elements, which will make more sense when you see some visuals. Now, if you can always come back to this page number 1 to have a look at, have another look at and read these keywords again, and it will make more sense. Compounds are made of more than one type of atom. They are just more than one type of element as well. So it must contain at least 2 different elements which are chemically joined together. And it's really important that you say that, because if there are 2 different elements present and they're not joined together, or they're not bonded together chemically, then you can't call them as compounds. Compounds are pure substances, and so are elements. Elements are also pure substances, which is different to mixtures. Mixtures are not pure substances. They contain more than one substance. Okay, we use the word substance quite a lot, and it just means that substances is a word that can be used to describe just about anything. But substances can be elements or compounds or mixtures depending on their chemical composition and what particles make them. So it's really important that you get, to understand that substance word is common to everything. Mixtures contain more than one substance, but it's really important to understand then they are not chemically bonded together. The substances are not connected together chemically. This means they can be easily separated. Good example is salt dissolved in water. Salt is one substance and water is another, and they can be easily separated. Let's have a look at how elements look like. We are going to be looking at how the particles that make the elements are different to compounds. These are examples of elements. This one here is helium, and over here you got chlorine. Okay, and if you look at the key definition we looked earlier, we should remember that for a substance to be an element, they should be made of just one type of atom, and this does fit the definition. It's only made up of one type of atom here. And again here you can see they come in pairs, they are connected. Seems like the 2 atoms that make up each particle of this element are connected, chemically bonded together, which is chlorine. So the chlorine, we call this molecule, more than one atom joined together. It can be anything. If it is more than one atom connected, we call them as molecule. So does this fit the definition of an element? Yes, it does, because if you look at each particle, they are made up of one type of atom only. So that is an element. So helium, chlorine are both examples of element. What if an atom contains 3 atoms stuck together? Well, all you have to look at is, are the 3 atoms the same? Now, if that is the case, then it's an element. For example, ozone has 3 oxygen atoms, just like this, connected together. And they are bonded together. And then what you see is this is ozone. And that's an example of an element as well, because all these are oxygen atoms. It's made up of 3 oxygen atoms. Okay, and that makes that an element as well. So all these are examples of elements. Now let's have a look at how compounds are different to elements at particular level. So we look at particles of compounds and they are different to elements, and it's really important to be able to recognize by just looking at the particles that make the compounds as compounds and be able to clearly distinguish between them. What you see here is a very common compound that we use every day. We drink this and it's water, very essential compound, and it's really important to distinguish this from elements. And this, if you look at the definition for compounds, it is that it should be made up of at least two different elements and they should be chemically connected together. So the atoms should be different, at least two different atoms present in each particle of a compound. So if you look at each particle of a compound, let's look at one of them. Each particle of water, we can also refer to this as molecule now, as we know if the particle contains more than one atom joined together, we can call them as molecule. So if you look at this molecule here, it's made up of three atoms, 1, 2, 3. They are chemically joined and they are called chemical bonds, and the bonds are shown here but not here, just for simplicity. It's hard to show the bonds every time you have a particle diagram where there's quite a lot of particles involved, and it's very hard to show them and see them. Just for simplicity, it's not shown here, but as you can see, they are chemically joined together. But what's more important to understand is that it's made up of three atoms but two different types of atoms. So this one is one type of atom, and that one is another type of atom. And as you probably know, the water is made up of hydrogen and oxygen. So these two are the hydrogen atoms, and that one is the oxygen atom, what you see in the middle here. And that's why water's formula is written like this, H2O, just to represent that 2 represents the two hydrogen atoms, and the O represents this oxygen atom. So this number 2 represents the two hydrogen, and the oxygen atom represents that oxygen atom. And as you can see, it's a liquid, and the particles are really close together, and a few particles escaping and they're evaporating out of the liquid. Now let's have a look at another example of a compound. What you see here is carbon dioxide in a container, and if you look at each particle of carbon dioxide, it's made up of two different types of atom. One in the middle, which is a black atom, and the two red atoms are of different type. This one represents carbon, and these two represent the oxygen atoms. So one of this molecule, they're all chemically connected, bonded. As you can see here, one molecule of carbon dioxide is shown here now with bonds, and it's not shown here for simplicity. And you can see there are two bonds here connecting the carbon atom with each carbon atom with the oxygen atom on either side. And it is really important that to understand that the atoms should be bonded and connected together. And how many atoms make this particle or this molecule? 1, 2, 3. So 3 atoms are present in carbon dioxide molecule, but there are only two different types present. That's one type, the carbon, and now you got the oxygen, which is of a different type. Okay, so two different types. That is the definition for compounds, and they are chemically joined, and that is a compound. It's also useful to recognize that this is a gas. As you can see, there is lots of space between them. So I'm sure now you would recognize the carbon dioxide formula, CO2, and be able to understand why that is the case. And as you can see here, that carbon atom, that symbol for carbon is for that one carbon, and that 2, the number 2 or on the O shows that you got two oxygen atoms present in the carbon dioxide. Let's now have a look at mixtures and look at closely at their particles and how they are different to compounds. It's really important to compare mixtures with compounds because these are the most easily confused substances. The example for mixtures here given here is sugar solution. So you got sugar dissolved in water. As you can see, the water molecules are shown here evaporating and escaping, and you got water molecules very close to each other showing that they are liquid, and sugar molecules are represented by this orange colored um, 3/4 of a circle symbols, okay, here. So each of these represent sugar molecules. And it's given here, the actual sugar molecule looks like this. It's pretty complicated, and many atoms are connected together, and it's a very large molecules. So the sizes don't represent the real sizes really. So the sugar molecule is pretty large, pretty huge, and they are mixed up with water molecule. Now, what makes this a mixture and how does this compare with compounds is really important. Now, this is one substance and this is another substance. There are two different substances. They're not chemically joined together and they don't have any particular proportion. You can add a little bit of a sugar and mix them together and a lot of sugar and mix them together. So there's no definite composition to them. Whereas in water, you can see that always there is a particular ratio. Every 2 hydrogen will have 1 oxygen. But here, sugar solution, you don't have that ratio between the sugar and the water. It can be mixed in any ratio. And also it's really important to understand that the sugar molecules are not chemically connected with water molecule. They can be separated out. So if you just evaporate, keep on evaporating the water away, you will be left with sugar in the container. So basically you can separate a mixture by physical means without doing any chemical reaction. Now remember, evaporation is not a chemical reaction. You just evaporating the water away and there is no new substance made. So that's what we call as a physical means. When there is no new substance made. You had sugar and water to start with, and at the end, after separating them, you have sugar and water, two different substances. Remember, mixtures can be made up of many different substances, not just two, but as a minimum you should have two. What you see here is air in a container. If you take a typical sample of air, it contains mainly this gas here, which is nitrogen. And look at the particles of nitrogen. And what your task, just to check your progress so far and understanding, try to figure out what air is made up of. Which of these particles are compounds and how you can describe air as a whole. Okay, so let's look at each of them and see if you can describe them. This is oxygen. This is essential for us to be able to respire using oxygen. That's water. Air always contains a few bits of water molecules in them, and we call that as humidity. That is carbon dioxide. It's present in a small amount in air. And as you can see, mainly air is made up of nitrogen, 80% nitrogen, round about approximately 19% oxygen, and a few other substances such as here. What you have here is gases of single atoms. They exist as it is, as one single atom, and that one here is neon, and that one is helium. Okay, so helium, and this one is neon. Okay, pause this video for a few moments and maybe write down what each substance is. For instance, you can describe them as molecules, you can describe them as compounds, elements, and also, more importantly, you can talk about the whole air as a whole as a substance in itself? How would you describe air? Check your answers now. This substance here is a molecule. You can describe that as a molecule, and it's an element as it's made up of one type of atom only. That one there is again a molecule, but it's an element as it is made up of only one type of atom. That is also an element, neon. Helium is an element, again one type of atom only. So far we have seen nitrogen as an element, oxygen is an element, and neon and helium. These are elements present in air. When we look at carbon dioxide, that and water, they are compounds. They are made up of more than one type of atom, as you can see. And what about air as a substance? Now it is a mixture, because you have many substances mixed together. They are not chemically joined. For example, nitrogen and oxygen, no connection between them. They exist wherever, in random order. There is no connection at all. For example, water is not connected with nitrogen or oxygen. So they are separate substances. Each of them have their own chemical composition. For example, water has got H2O, nitrogen N2, and together, they are all together, we call as air, and it's a mixture. This brings an interesting question. Can you separate all these gases? And if it is a mixture, it should be possible to separate them. Yes, it is possible to separate air. You can research about how it is done. Now let's have a look at how chemical formulae is written for these substances, and we should be able to understand what the numbers and symbols mean. For example, have a look here. We're going to start with carbon dioxide, and the chemical formula for carbon dioxide is capital C, capital O, and a small 2 here, as you can see here. Okay, let's make sense of what this formula means. That carbon represents that carbon. It is to show that each molecule of carbon dioxide is made up of one carbon atom and 2 oxygen atom, shown here as O2. Similarly, for oxygen, it's written as O2. Remember, it's a capital O, and we should also bear in mind that if you have a capital letter, that represents one element. And let's look at this one. As you might possibly guess, it's N2. This is 2 nitrogen atoms here. Now let's have a look at these two substances. What do you think they are? Are they elements or compounds? You should have recognized that both these substances are compounds, and we're particularly looking at how to write the formulae for them. And if you look here, it contains 2 hydrogen, 1 sulfur, and 4 oxygen atoms, and that can be written as H2 for the 2 hydrogen atoms, and S, which is a capital S and a capital O, H2SO4. And that is sulfuric acid, formula for sulfuric acid. And what you see here is methane gas, and that is a compound as well. And you write the formula for that as CH4. That carbon is there, 1 carbon, and that number 4 represents the 4 hydrogen atoms. It shows that there are 4 hydrogen atoms present in each molecule of methane. You should also be recognizing compounds now from just the molecular formula without its full structure or any other image. If you just look at the formula, if it contains more than one capital letter, that itself shows that it's made up of one element, more than one element, and it's a compound. For instance, you should be able to say how many elements make sulfuric acid. You just have to count the number of capital letters here. 1 here, 2, 3. There are 3 different elements that makes up sulfuric acid. Now you can get the names of these elements from periodic table. So if you're asked about what name the elements, you can look at the periodic table. Have a look here. That's methane and carbon and hydrogen. You can see there are two capital letters showing that there are two different elements that make up one molecule of methane. You have now reached the end of this lesson. You should be able to now look at a formula and say whether the substance that you're looking at is an element or is it a compound. And you should also be able to say how many elements that substance is made of if it is a compound, and how many atoms make that substance, one particle of that substance. In most cases what you see here are molecules, but there are some which are not molecules. So you should also be able to say whether the particles that make each substance, if it is a molecule or if it is not a molecule or it's just made up of atoms. Okay, let's start with water here. And you can pause the video now to actually try each substance and then look at the answers. Water here is a compound because it contains two elements, hydrogen and oxygen, and you can say that by just looking at the capital letters there. And so it's made up of two elements. But if you want the number of atoms that makes each molecule of water, you need to look at how many atoms of hydrogen is there. It's two hydrogen here and one oxygen. So that means it's made up of three atoms altogether. So for just water, you can describe that it's a molecule and it is a compound, and then it's made up of two different elements, but it's made up of three atoms, two hydrogen and one oxygen. And now for oxygen, now this is an element because it's made up of just one type of atom, which is oxygen, O, and each molecule contains two oxygens of atom. Okay, so each particle of oxygen is a molecule, and it's two atoms of oxygen that makes that molecule. Methane is made up of two elements, carbon and hydrogen, but the number of atoms that make each methane molecule is one carbon, four hydrogen, so that's five atoms altogether that makes methane molecule, and it is a compound. Calcium carbonate, that's a compound as well, and it's made up of three different elements. Remember, one capital letter makes just one element. So this Ca, although it's made up of two letters, because it only contains one capital, it counts as one element, as it's got one capital letter. So remember, you're only counting the capital letters. Ca, that's calcium, that's one element. Carbon, another element, and oxygen, another element. So this compound here is made up of three elements. Now let's look at how many atoms this is made up of. 1, 2 plus 3 oxygen, that's 5 atoms altogether. So this compound, each particle of calcium carbonate, is made up of 5 atoms, but 3 different elements. Let's have a look at oxygen. Sorry, this is not oxygen, this is ozone. Ozone is made up of 3 atoms. Each molecule of ozone is made up of 3 oxygen atoms. Now, as it is just one type of atom, it is an element. Helium, it's not a molecule, it's just atoms. So this gas, the particles of this helium gas exist as atoms. It's not a molecule, as it can only see one capital letter and there is no numbers here, so it's just helium element. It's made up of one element, and it's not a compound, and it's not even a molecule. It exists as single atoms. Ammonia, NH3, that's a compound because you got two elements, nitrogen and hydrogen. If you want to know the total number of atoms that's present, 1 plus 3 hydrogen, that makes it 4 atoms altogether in ammonia. In copper, again, it's a compound, copper oxide, and it's made up of 2 different elements, copper and oxygen, and the total number of atoms is also 2, 1, 2. Finally, copper carbonate. You have three elements that makes it. Cu is one element, second element, third element. Cu is one element, carbon is another element, oxygen is another element. So that's three elements making copper carbonate. How many atoms are there in copper carbonate? 1, 2, 2 plus this 3, that makes it 5 atoms that makes copper carbonate. On the next slide, we're going to be looking at how you recognize elements present and the number of atoms present in formulae, which includes brackets. What you see here are two different substances. Each have brackets in their formulae. So if you look at copper nitrate formula, you have a bracket here. There, it's got a specific meaning. You just have to multiply this number in with each of these numbers. Remember, when you don't have any number, as in the case of nitrogen here, that means you have only one nitrogen atom there. And copper similarly has got one atom of copper in that formula. So let's have a look at how to deal with formulae like this. If you were to find how many elements are there and how many atoms are present, and this is also useful later on when you try to work out the molecular masses of compounds. So let's have a look at this. Now, if you look at the first compound, copper nitrate, I suggest that you expand this out like so. So I'm going to multiply the numbers in copper, and 2 times that N1, which is, so I'm going to now multiply 2 with that 1, that gives you N2, because 1 times 2 is 2. Now I'm going to multiply 2 with that 3. Okay, so that makes it 6 oxygen atoms. It's better to write like this to see how many atoms are present in that compound. And now it makes it easy to count. 1 copper, 2 nitrogen, and 6 oxygen. 3 elements, but the number of atoms are 1 plus 2, 3, 3 plus 6, 9. So there are a total of 9 atoms that makes this that compound. Okay, now we're going to be looking at this compound here, ammonium sulfate, and I'm going to expand this out in a very similar way to what I've done about in the case of copper nitrate. So I'm going to expand this out in the same way. So this is 1. Remember, when there is no number here, that means it's 1. Multiply that with that 2, that leaves you with N2, like so. So I'm going to write it like that, and then you got 4 hydrogen atoms. Multiply that with this 2, that gives you 8 hydrogen atom. So I'm going to write it like this, and then there's no need to multiply this, just written as it is. So SO4. Okay, now you can pretty much see how many elements this is made up of. 1, 2, 3, 4. 4 different elements that makes ammonium sulfate. But if you want to now know the number of atoms that makes this formula or this compound, you can see here 2 nitrogen, 8 hydrogen, that makes it 10 so far, 11 plus that 4, that gives us 15 atoms that is present in ammonium sulfate.